So in this class, we will learn name hiding, and also upcasting. So we just mentioned that if we define a same name function with the same name, so this name exactly the same, right? Same name as the base class, then this function will hide the base versions. So in this case, these two versions of the base class cannot be called, even they are inherited, because we use public inheritance. They are inherited, and they are actually should be accessible if we do not define this. However, because we define this same name function, it hides the base version, right? So this is name hiding. So this is in the context of public inheritance, and public inheritance, and we define the member function in the base class with same name, and possibly with different function parameters, return types, and function body. In this way, the effect is objects of derived class cannot access inherited public members of the base class. Okay. All overloaded member functions will not be able to be accessed, cannot be accessed. Both const and non-const member functions are hidden. They cannot be accessed. So here is a more detailed example. Okay. So in the base class, we have this F and G. Derived class, we define this G. So this one hides this base version, right? This one hides this base version. And then derived 2, we also have this. This one also hides the base version F. Okay. This one also hides the base version F. Okay. Then in derived 3, we also have this. So it's also even we have different return type, it also hides the base version. And we can also change the argument list. It still hides the base version. So in this case, we can define, we can call the version defined in the derived class, but we cannot call the version in the base class. Still is hidden. Okay, so this grammar I don't think is too difficult. So it's left for you to play more with this and try this example and try to compile it and run it. Our question is how to avoid name hiding. If we want to access base version, how to do that? There are two ways. One is a forwarding function. Another one is using declaration. Right? So these are the solution. For example, this is base class and the derived class. And then this is using. Right? If we define in the derived class, we define this function. And then if we want to again access the base version, we can do this. We can, by using, we expose these two interfaces in the derived class, then we can access it. And also, in this case, we have different return type. Still, we can do using. We can do using. And then this is forwarding function. Forwarding function means we just directly call in the function body of the derived class. We can directly call the base version. We are forward the base version or base function into the function body of the new member function. Right? So this is forwarding function. And so this is change argument list. Then it works. So there's 2 ways. Now we have this class pet and another example, class pet and class goldfish, and we have this public inheritance, and by using, we can expose all the versions of the sleep. There are 2 versions actually. Now it's okay now, it works. However, in previous years, some students ask this question, if we do using in this way, then these 2 versions will be exposed. All the 2 versions can be accessed. How to expose only 1 version? For example, if I only want to expose this version, I don't want to expose this version. How to do that? I think there are 2 solutions to this. One is still, again, forwarding function instead of using. We know that forwarding function, we define the function, and in the function body, we use the base version. Right? We call the exact base version we want. So in this way, we do not expose all the versions. And also, we can redeclare. There are another ways to redeclare. We have exposed the 2 versions like this, but we can still redeclare as private. This one, right? So in this case, this version is exposed, but again declared as private, so that it cannot be accessed. So these are the 2 ways to solve this problem. Now we learn something about the comparison between composition and inheritance. Actually, they are similar in code reuse because both of them can be used to reuse, can be adopted to reuse existing class. And both of them will place base object into the derived one. For example, this is inheritance. By inheritance, these members, either data members or interface members or function members, are inherited into derived object, right? We can use it. But composition, again, these members, all the members, data member and function member, are inherited into the derived object, right? So both of them place, we call this sub-object because we may define new members. These are the subparts, right? Subparts. So both of them place sub-objects into the new class, and both use member initializer list to initialize. So this is grammar. We know that. So these are the similarity between them. For difference, for composition, public composition can directly access member objects. So we know that, right? Already know that because it's public. Public members can be accessed. Private and protected members cannot be directly accessed. We have to define new interfaces, right? And the composition follows has a or is implementing in terms of. So we has this composition or has this part or have this this part of the object, or we just implement a function in terms of using this existing class to implement a more complicated function. For inheritance, it follows is a relationship for public inheritance. We know that. So this means director class has all the public interfaces of base class. So wherever base object is used, we can use a derived object. So for private or protected inheritance, we follows is implementing in terms of. So actually, in most cases, we just use composition instead. Okay, then this is inheritance, and here's an example. For example, this is private inheritance. By default, is private, right? So this keyword can be omitted. So we define a class person. Actually, there's nothing inside, and we have the class student, and we have the function it, which takes the person reference. Then we can see here, we call this function with two objects. So we can actually, this does not work, right? So that means because we have this private inheritance, right? It does not follow is a relationship, right? So this fails. We cannot cast by private inheritance. We cannot cast from the base class, from the derived class into the base class. Okay. So this actually related to upcasting. So if we want to convert a reference or a pointer of the derived class to a reference or pointer of the base class, we have to use public inheritance. If we use protected or private inheritance, we will fail. We will fail in that. Okay. So actually, we move up the inheritance diagram. This is also called UML, Unified Modeling Language of this diagram. So we go up in this diagram. So we are doing upcast, casting up, right? Casting up. That's why we have this name, upcasting. Okay, then if we have this public inheritance, then this works. This works. It's okay now. Another example is that this instrument. So we have a wind, and we have this tune which takes instrument reference. Then we can upcast, right? We call this wind object like this. We can upcast the wind wind reference to an instrument reference. So this is upcasting. It works for this public inheritance. Okay. Okay. Then due to time limit, we have to stop here. We will learn. Okay. From last class, we learned upcasting. Before class, I want to mention something. In our last class, we learned the inheritance of the sorry. From last class, we learned the inheritance of constructors, and someone mentioned that actually the constructor in the base class can be inherited. By using, right? By using. So here is an example in the book, beginning CPP 17. So we can inherit the constructors. So in this way, by using, we have the base class, and then we can inherit all the constructors of the box class. In this case, we can still define our own constructors of the derived class. However, there are still two more constructors generated by the compiler because we have this statement. So the compiler will generate two more constructors for us. These are the two more constructors because in the box class, we already have two constructors for box. By this using statement, all the two box constructors are inherited. So the compiler will generate two more constructors for us. These are the two more constructors generated by the compiler. You can see here, the difference is that compiler generated the constructor will have exactly the same parameters as the box constructor, right? So because for this version of the box constructor, there are 3 parameters. So the carton the constructor will take 3 parameters. So they exactly match each other. So then the arguments will be passed directly into the box constructor. So in this case, if we define some new members in the carton class, then there may be some issues, you know, if we do not provide some default values for the members, then there may be some issues, right? So I still suggest our students to use to define the constructors directly. Okay, so in this case, maybe some careless errors may be avoided. Okay, so this is left from last class. Now we'll continue to learn this constructor because we have learned upcasting. Actually, the copy constructor depends on the okay, someone asked a question. 用了 using 派生类的 constructor 和基类同名。用了 using 派生类的 constructor 和基类的同名同参。I think there may not be a problem if you think I think you are mentioning about this, right? So if you define this carton constructor in this case here, and then you type using here, so you're mentioning if there will be 2 versions of this constructor, right? So I don't think that will be a problem because I think the compiler will be intelligent enough to avoid it. Okay, so you may have a test. I guess there should not be such a problem. So the compiler will avoid this version. I think the compiler will avoid this version and use the user-defined version in this case. Okay. Okay. So for a constructor in the inheritance, we have an example here. So to test the constructor or copy constructor in the inheritance, we have the base class, and we have different versions of the constructor. This is a constructor, and this is copy constructor, and this is default constructor. This one is stream operator overloading, actually. We have not learned this, but I think even we can learn it here, right? So this friend is a keyword so that we can declare an ordinary function or general function. So this operator function is a general function, actually. You can just take this. You can just take this part as the function name. Okay, it's similar to a function name. Then you are defining an operator, stream operator function. Because you have declared this as a friend, so you can directly access all the members of the objects of parent. So you can do this, b.i. Otherwise, because I is private here, otherwise that's not possible. So this friend will break the access control. Okay, by declaring a function as friend of a class, you can freely access all the members or all the private members of the parent class. Actually, this friend is not necessary. You can still avoid it. I think in most cases, because you can have an interface member. You can do this, right? Get I, right? You can have accessor, so you can still get your function, right? Get your data without violating the access control or data hiding mechanism. Okay, so I don't think friend is actually, in most cases, friend is not necessary, and we can avoid it. Okay, and this is friend, and for this operator function, by defining this function, actually we for example, if we use actually this for example cout. Cout is an object of derived class of O string. Okay, if we say, for example, you say out something A, then actually we are calling operator cout A. So we are calling this function. So by defining this operator here, we can enable this if A is an object of parent. Okay. So in this case, we can enable the dump, dumping the members by this operator. We can use cout, for example, to dump the object content in this case. Okay, by returning a reference to this O stream again, that means we can do this. We can do cout, for example, parent A and B. We can do cout A, B. We can do this, okay? Because for this first one, we are calling operator cout A. Then we are calling this function. And then after calling this function, we return this cout, right? Return this cout. So this function will return a cout. So when we call the second one, we again call this operator. We again call the operator, right? Because this is cout. Then we will again call this operator operator B, right? And then we will call this NL, right? Here and cout. Like this. So in this case, we can define such an easy way to dump the content of objects of the class. Okay, so this is, I think this is a typical grammar, so you can just memorize it. Okay, in this case, this is the variable. You cannot be careful not to use cout directly here, so that's not allowed. Or you cannot use cout here. That's not allowed because we are defining operator for all stream objects. So we should return OS, or if you define it in another name, you can return. You should return it. Okay, so this is grammar for dumping the content of the classes. Okay, and then we can define a member class. So in this member class, we have constructor and also copy constructor, and also this operator overloading. Okay, to dump the members. And then we have this derived class of from this parent class. Then we have a member object here, and then we can define a constructor. Actually, then we dump. Right? We dump here. If we dump it in this case, we are doing upcasting. We learn upcasting, right? Upcasting works on reference. So we can upcast a child object. This is child object or child reference to a parent reference. Then we can call the already defined operator for the parent. Right? We can dump that part. Then we can dump then we can dump the member, right? This is member. We already defined the operator for this member, so we can dump it in this case. Okay, so in this case, we can easily write the operator function in this case in this way. Okay, here we can see that there's no copy constructor. Right? We do not define the copy constructor. How will it work if we call this? We know this statement calls the copy constructor, right? This one is copied to construct C2, right? So what will happen? So this is output. From the output, we can see that. First, the parent. So this is child construction, right? And then this part is for this child C, right? Then calling the copy constructor, and then we can see here the copy constructor for child calls parent and member constructor. So actually what happens is that the constructor automatically generates the constructor for us, the copy constructor for us, for the child class. So this child generated copy constructor calls our defined parent copy constructor and member constructor, copy constructor. So in this way, it works correctly. Right? The variables are correctly copied. We get the correct answer, right? So this is an example. If we do not define a copy constructor, compiler will generate one for us. Right? But we have learned that we should never depend on the compiler. Right? We should never depend on the compiler for constructors. Even copy constructor, we should not depend on the compiler, because if there are pointer members, probably there will be some errors or bugs. So we should write our own copy constructor. How to write it? We may write it in this way. Does this work or not? We have the child. We want to copy child. Then we copy member, and then we copy I from the child object. Does this work or not? Actually, it does not work. Originally, we know that this is output. If the compiler generates one for us, we get the correct answer. Values are correctly copied. However, if we use this version of the copy constructor, we define this, then output is like this. So because here we did not provide how to copy the parent part, right? The parent object. So we did not define that. So our defined copy constructor will call the default constructor with nothing, right? With no parameters. So in this case, by calling this default version of the parent constructor, so the value is assigned 0. So this is wrong, right? This is wrong. This is not what we want. So this default constructor of parent should not be called, and we should call the copy constructor for parent, right? So how to write the copy constructor for parent? So we should define the copy constructor. Either we do not define it, and that means we declare it as private to disable it, right? Or we define it completely. How to define it completely? This is the way. This is the way. So we can see here, we construct the parent by C, right? However, we know that this parent constructor takes a parent reference, right? So here is an upcasting. We are doing upcasting from C to a parent reference. So upcasting is used here to define the copy constructor. Okay. then we can assign I and member similarly. Then the copy constructor is called as expected, and it works correctly now. So this is the grammar for defining copy constructor in inheritance. And we need to memorize this grammar, okay? And here is an example. We can still do more. One is copy constructor we just learned. Another one is move constructor. This move constructor. This is copy constructor. You can still do more by defining the move constructor. And move constructor also depends on upcasting. Right. So by the move constructor, this move will return a parent reference. So we are still doing an upcasting here. And also for member, we have this move. Right? In this case, we can define a move constructor in this way. And this is the original copy constructor by upcasting. Okay, so these are the grammars. I hope you to take some time to memorize this grammar. And these are the results. Okay. Actually, we have the demo, but I think this demo is yes, move constructor. Yes, we can see here when we call the move constructor, we expect that this move after calling the move constructor, this part is not used anymore. This part is going to be released. So that's the definition of move constructor, right? This is I think this is a good question. Because this move constructor, I think because it calls upcasting. I think it is called upcasting, so it will这个可能跟这个定义有关啊，就是说具体我们比如说这个 move 的时候啊，这个C 的这个 move constructor 是怎么样定义，对吧？然后这个里边有没有做这个这个对应的这个 delete 什么东西啊？但是我觉得这个里边应该这个是个好问题啊，我不知道大家有什么看法啊？就是这个，我目前的想法就是说，这个 so my current idea is that because we are calling a move constructor for this, and we are doing upcasting in this statement, so only the parent part is invalidated. So so this part may not be invalidated. This is yes, I think only the parent part is invalidated. So this part is still accessible. And this part also accessible because this part deals with the parent part. So different parts will be invalidated in sequence. So that will not affect the results. this is my current idea. I will record this, and I will also think about it more. And if some students have some more insight in this, we can communicate and we can discuss. Okay. Thanks for this very interesting question. Okay. So due to I think this is there's an example, but the example is really due to time limit, we will not go into detail of the example. The example is exactly the same as this code. Okay, you can try it and compile it and run it. Okay. Anyways, I hope you to remember this grammar. If you remember it, it's not. If you try to understand the insights, the principle, so it may be a little difficult, but it should be helpful for us to understand the grammar in more detail. When we understand it, it should be easier for us to memorize it. Okay, so I still encourage you to try to understand how the grammar works. Okay, that's very good for learning programming languages. Okay, and then we continue to learn this object slicing. So we have learned upcasting that works for pointer and reference. However, if we upcast on objects, then it is object slicing. Okay. So if we upcast from derived object to base object, derived object will be sliced to a sub-object corresponding to the base class. It's like this. So this is a derived object. And then if we upcast to a base object, then this part will be lost. This part will be lost. Okay. So this is object slicing. There will be data lost. Okay. Then we have this class path example. We have class path. We have the member, constructor, and member function. And then we have derived class. We have a new member in the derived class, and then constructor and member function. Now we slice, object slice, right? Slice object by this function. It takes a base object. However, we call the base object. We call the base object. We slice. We call the function by both base object and derived object. In this case. So because we follow public inheritance, we have already learned that by public inheritance, a derived object is a, right, follows is a relationship, is a base object. So this works, right? This works. And this derived object will be sliced to the base object. This is the output. This is output. Let's check it. So we'll check the output in this example. I think we have the. I think we have this example. Oh, it's maybe not this. We may not have this example actually. Okay, then this is another example. Okay, forget it. Sorry about that. I think you can try this example on your compiler and check the results. The results should be similar to this. Results should be similar to this, and from the result we can see that originally, because we have one member in the base class, so the size is 4, and then if for the derived class we have another new member, so the size is 8, and then in this describe, both sizes 4. This verifies that the derived object, after calling this function, the derived object has some data loss. Is sliced into the base object, so the size is different. Okay, so our design principle is that we should try to only cast on these references and pointers. Should try to avoid this object slicing, because there are some data loss, and sometimes it may not be safe, right? Because there are data loss. So this is our some knowledge on, or some grammars on upcasting, both for references and pointers and for objects. On objects, it causes data loss, and it is called object slicing. Okay, more on upcasting. For this case, here is an example. We have this example. We'll check. So in this example, we can see here we have this is the enum we learned before. So this is class instrument. This is base class, and we have a public member function play, and it outputs instrument play. Then we have a derived class wind, and it follows public inheritance, so it follows is a relationship. So, and then we override this play function and outputs wind play with sound. Right? Then we have this tune. It takes instrument in reference, and then we call the play member function. Then in this main function, we first define the derived object, then we call tune. So from here we can see that because we have a wind object here as a parameter, but it takes instrument reference here. So we have upcasting, right? The wind reference will be upcasted to instrument reference, and then its play function will be called. So this is a tune function call, and then we can call it another way. We explicitly upcast from this fruit pointer to instrument pointer, and then we call this member function again. Let's check the results. So we can see here we have 2 lines, instrument play and instrument play. So although we have this wind object here, but because it is upcasted to instrument reference, so the compiler will call this instrument play, no wind play. If we really want, because it is wind objects, if we really want it to play some sound, how to do that? How to do that? The solution is, we will learn this today. Solution is put a virtual keyword here. Put a virtual keyword here. Then it will work. This enables polymorphism. The virtual keyword here, we can see here. So the output is different now. This is wind play with sound. So this virtual keyword is the key to enable polymorphism. We will learn this today. Okay. So this is example. So we can see here. So how to solve this? We know that we have to use virtual keyword and enable this polymorphism. Okay, then this is lecture 8. Now